Alright, we're going to try to do this without the book, so hang on.
In this video, we'll see how the Lorentz transformations can be used to understand velocity addition and the relativity of simultaneity in special relativity.
Into the stone mill.
Let's start with how velocity addition works in special relativity.
Geometry, which is a circle,
Let's say
square,
that Albert Einstein
triangle,
is standing still on the ground.
The cant, which is a triangle, which
a
is
train
a square,
is going by to the right
x
at
squared
90% the speed of light.
Gives me, alright, so the whole Big
Hendrik
Bang
Lorentz
spectrum.
is on board the train and fires a gun towards the right. The bullet travels out from the gun at 90% the speed of light relative to the
I'm sure if
train.
you exposed to it a long time, like UV,
So it's interesting to ask how fast the bullet is traveling in Einstein's frame.
It's going to be you in a microwave. You might get warm.
Figuring this out would involve changing reference frames twice.
Gamma. In between
First
these
from
areas
Einstein
right
to
here,
the train,
some visible light
and then again from the
spectrums and
train
some
to
stuff
the
you're
bullet.
doing. The train to the bullet.
In Galilean relativity, we'll
else
find that
for
the
an
speed of
IQ
the
test
bullet
on
agrees
stuff
with
and
common sense.
Einstein's field
But
theory
in
works
special
because it's
relativity,
back
the
to
answer is more surprising.
our standard model.
Let's start by looking at the
they
problem
did
in Galilean
I wrong,
relativity.
T wrong, it's just a cheat code. And we're
Let's
going
say
to talk
that
about
Einstein
why
uses
we want to start
space-time
with
coordinates
A
t
first.
and x.
This is what it means.
The train uses
2, 3, 4.
coordinates t
The
tilde and
coordinates
x
are
tilde.
hot and low.
And the bullet
Kind
uses
of sets in here,
coordinates
and this
t
is going to
smile
be
and
plus
x smile.
equals F1 plus F2 equals
The
minus
Galilean
F1.
transformation from
M1,
Einstein
M2,
to the
M
train
We're get into all
changes
that
t
here.
and
This should
x
be A,
into
or
t
0,
tilde
1,
and
1.
x tilde,
In
using
order
the velocity v,
y
which
of
is
F
the
or x
velocity
to
of the train
position 0,
according
1
to
correctly,
Einstein.
and know which one is the
And
first
the Galilean
orientation.
transformation from the train to the bullet
reset button,
changes t
step
tilde
button.
and x tilde
You
into
need
t
this to be
smile
A,
and
because
x
steps
smile,
work in A
using the
and a
velocity u,
gambit.
which is the
Alright,
velocity
so
of
if
the
I'm
bullet
using
according
T
to
or
the
A
train.
or whatever, A would still work
To see how the
congruently
velocities
to B.
add in Galilean
A
relativity,
first,
let's
sequence
combine
T.
these two
When we start
Galilean
T, it's actually,
transformations
what,
together
20,
to get a new
there's 26
transformation
letters in the
from
alphabet, what,
Einstein's
13,
coordinates
A, B,
to
C,
the
D,
bullet's
E, F,
coordinates.
G, H, I, J, K, L,
Time
M,
in
N,
Galilean
O, P,
relativity
Q,
is
R, S,
universal
T.
for all reference frames.
15,
So t
we're
smile
at 1,
equals
5.
t tilde
Maybe I could
equals
cheat
t.
that shit. But this
for
is
position,
math,
let's start
cross
with the
number,
equation for
Euclidean
x smile,
geometry,
then
into the
substitute
stone
in the
mill.
equations for
And
t
so by
tilde
doing
and x
A
tilde.
to T, I'd
If we
still get
factor
a
out t
timeline
from
in the
these
stone mill.
terms, we
Time
see that
has
we get a
right-hand
new
rule
Galilean
to this
transformation
special
that changes
relativity
x to x smile,
0,
using the
1
velocity
system.
u plus
And these
v.
are real straight lines.
This
Polarized
shows us that to combine
back to the
velocities
spectrums.
u and v in Galilean
atmosphere,
relativity,
air particles,
we literally
stone mill
just
stuff.
add them together using the plus
Hydrogen
operation.
is A. That's what all
This
this
agrees
kind of
with
does
our
with the
common
moon
sense
and tau,
experience
and
that the
not
speed of the
A
bullet
clean.
on the train should be
When you
added
get into
together
Feynman
with the speed of
diagrams,
the
I
train
could do that in
relative to the
stone mill,
ground.
a weekly count with
So
the
this
bi-weekly,
seems like the obvious
the 4
answer,
days
but we'll
on
find
this
that
with
it's not true in special
the
relativity.
straps right here with the bander and the chain.
Another way to get this result is to write out the two Galilean
And if you ever
transformations
watch
in
something
matrix
like
form, writing the
what is
space-time
it?
components in columns and converting between them with
Fundamental
Galilean
analysis,
transformation
the teacher
matrices.
will write out equation like this.
We
Change
can
out these
start with the
bottom
matrix
ones.
equation,
Erase
converting
this.
the
Pull
tilde
the board back up
coordinates
and do
into
it.
the
And I
smile
want you to understand,
coordinates.
in a business,
And then
that happens a
substitute
lot. We're
this
talking
matrix
about the change
equation
rail,
in
a
for the
mechanic,
column with t
in
tilde
the entire
and
day
x
system.
tilde.
This kind of system
Next,
would
we
be
can just
A1
multiply
still,
the
but we
Galilean
had to slide
matrix
it out
with
to
speed
1.5.
u and the
The
Galilean
1.5
matrix
becomes the
with
first
speed
system
v
that's
to
kinda
get the
like,
new Galilean matrix with
this is
speed u
polarized
plus
wave
v.
functions into a
And this gives
hurricane
us the
problem.
combined Galilean
Shit's
transformation
dragging
that
diamonds,
changes
man.
from Einstein's
These
coordinates to the bullet's coordinates.
Is Casino Vegas.
With
This
this
is
rule
Shangri-La.
for
You
velocity
pulling out
addition,
diamond
if we
diagrams.
take c to be the speed of light, then 0.9c added with 0.9c gives us 1.8c.
So,
1.8 times the speed of light. This means that in Galilean relativity, we can make some, and this gives us an equation converting from x in ct to ct
if you don't use
smile.
colors, you got to use like prime.
We can do the same
degree,
thing for the x smile
asterisk,
equation,
number symbol,
which gives us an equation for converting
and that's how
ct
you
and
stay away
x
from
into
A
x smile.
in the 2 phase, because A in the 3 phase after you
So
built
these
that
are the
whole entire
equations for
matrix
converting
could be
Einstein's
this,
coordinates
and
ct and
arbitrarily,
x into
that's where
the
the
bullet's
number theory
coordinates
gets wrong,
ct smile and
using
x
something
smile.
like Einstein's model to
Another
pop
way
out
to
dark
get
matter,
the same
because those
result
things don't
is
pop
to
out a
write
bunch.
the Lorentz
Everything's
transformations
dark matter.
in matrix form. Again,
Everything
writing the
is
components
dark
in
matter.
columns and transforming them
Well, the
using a
reality is,
Lorentz
see how I did
matrix.
this?
Their combined velocity,
You
according
just
to
started an
special
operation with a
relativity,
problem.
will also
It
be
was this
between
problem.
0 and 1. And here's the proof for that.
Close to 0 and 1.
I think we can all agree that 1 plus beta v equals 1 plus beta v.
Now's the time.
What might be less obvious is that beta u minus 1 is less than beta u minus 1 multiplied by the fraction beta v.
Is less
Keep
great
in mind
than
that since
the
beta
saw
u
mechanics
is between
beta
0 and 1,
that you're doing, which
then the
is
left-hand side, beta u minus 1
less
is a
than
negative
1.
number.
And if you do u,
and on the right-hand side,
saw
since we're
transformation
shrinking the
over
size of this
with the
same
steps,
negative
which might be
number
congruent
by the
to
fraction beta
what
v,
part,
this
what
will also
system
give us a
in this
negative number,
fractal
but
right
it's
here,
scaled
what
to be
actually is
closer
happening
to
when
0.
threw
This
that
means
over
that the
divisible
left-hand side
and said
is a more
derivative L
negative
over
number
derivative t.
than the number on the right-hand side.
1,
And
they're
therefore,
both still
the
close to 1
left-hand
and 0.
side is less than the
Throw that
right-hand
matrix
side.
around, hit the button, the toggle.
Now, if we take this
minimax
inequality
this thing
and
hedging,
add 1 plus beta v
hedging
to
on the
both
area
sides,
of that by the graph,
then the
and I see,
inequality
oh, I'm
shouldn't
making
change.
success on a
We're
lens,
just
on a
increasing both
positive
sides by the same
index
number.
of this being a 0.5.
Now, on the left-hand
we're still
side,
flat universe.
positive 1 and negative 1 cancel out.
And
on the right-hand
switch
side,
button,
after we distribute beta v
change
into
color
here,
to
we
beeping it
notice
over,
that the
and then
positive
so
beta v
this
and the
is
negative
me
beta v
in that
cancel
beta
out.
position running the saws.
So we're
This
left
could
with
be you
beta
doing
v
it.
plus
And I don't know
beta
the
u
orientation or
is less
position
than
just yet, 'cause they're
1
up close
plus
to
beta
zeros
v
and
times
ones.
beta u. Since 1 plus beta
Danger
v
Dave.
times beta u is
Shake hands
positive,
with this danger
we can
noodle.
divide both sides of the inequality by it without changing the inequality. If this was a negative number, we'd have to change the direction of the inequality. But because it's positive, we can leave the inequality sign as it is.
So, you know my stone mill models. I have a few on the internet. This isn't just graphing. This is that quadrant where I'm doing the banders or I'm fluffing the pile right outside the door. There's the camp pile where I'm the 8-footers, 7-footers, then there's concrete wall, then there's a ditch and a culvert. We take the forks, fluff that all up, grab a container, start kicking rock in it all the way to the office kind of day. Or we slide it a couple of degrees to this thing, we just run cants on the normal count, and that also works. And maybe we bend this line over here and warp reality a little bit, and you do a couple of, you feed the chipper, you do your basic deal.
So events that are simultaneous in one frame will not be simultaneous in another frame.
Check.
Simultaneity is relative
here,
in special
daytime.
relativity.
Over here, not daytime.
Now, after learning about the relativity of simultaneity, you may have some concerns. For example, let's say that at one event in space-time, we fire a bullet from a gun, and then a bit later, the bullet hits this phase, which shatters into tilde equals t.
Now that you know
for
that,
position,
we can do
let's
this
start
again.
with the equation for x
Tilde
mile,
moves,
then
man.
substitute in
Tilde.
the equations
That's how I
for
want you to
t
remember
tilde
it.
and x tilde.
Battle buddy, I love you.
If we factor
are on
out
the same
t
militia.
from these terms, we see that we get a new Galilean transformation that
Hit the
changes
next graph
x
because
to
that's
x
still
mile, using the
A1,
velocity
B1, you
u
hit me
plus
with a problem.
v.
I'm a mathematician. You expect
This shows
math.
us that
You
to
want
combine
this
velocities
to
u and v
what
in
exactly?
Galilean relativity, we literally just add them together